Well, good morning. Today is Tuesday, April 14th, and it is the start of our distance learning program.
From a distance.
You all should be added onto Google Classroom by now, and you'll be getting some schedules from me at the beginning of each week that has the weekly agenda. A video like this will be posted the first day of every week, so that the first day of that week will be your assignment to just watch that video.
From a distance.
I'm going to go over the answers to the 4 challenge problems from a couple weeks ago that I gave you. So if you want to just skip over that, you can. You can jump to this time right here to get the review questions. We're going to be doing some Delta Math questions. Some of you have already added onto Delta Math to get the problems that I assign. If you haven't already, please go to deltamath.com and type in the code 908861. And that will get you joined onto my platform.
From a distance.
So for the first challenge problem, we're asking, how can we make 13 over p squared minus 3 a positive integer, right? And so the good thing is that this number here on the top is prime. So there's really only 2 possibilities. Either I have 13 over 13, or I have 13 over 1. There's no number that I can make on the bottom here, 13 over something, that would make it a positive integer because you would get a decimal. So really what I have here are 2 possibilities. Either p squared minus 3 is equal to 13, which means p squared is equal to 16, which means p is equal to plus or minus 4. Now the problem does say, what is the sum of the positive integers? So the positive integer for my first solution would be 4. And if I'm going to set the bottom p squared minus 3 equal to 1, well that means p squared is equal to 4, which means p is equal to 2. So the sum of the positive integers is going to be 4 plus 2, so my final answer there is going to be 6. For the second challenge problem, we have an equation that looks something like this. Now, notice the top and the bottom are perfect square trinomials. If I were to factor that as x plus 1 times x plus 1, we can call that x plus 1 quantity squared. The bottom one is x plus 3 times x plus 3, so we can call that x plus 3 squared. And look at these numbers over here, 36 and 49, also both perfect squares. So if I'm going to solve for x, I can take the square root of everything, and I can be left with x plus 1 over x plus 3 equals 6/7. Now here's what I notice. Whatever value x is, this plus 1 and plus 3 differ by 2. So if I go ahead and multiply these by 2, this is going to give me 12 over 14. Notice how these integers differ by 2. And so now x plus 1, if that's equal to 12, is going to be 11. And x plus 3, if that's equal to 14, also works that it's going to be equal to 11. Final answer, x equals 11. And for challenge problem number 3, we were talking about this factorial business. We had talked about where factorial is every integer less than that value multiplied. So 5 factorial is 5 times 4 times 3 times 2 times 1. I'm going to write out the top of this, which is n factorial quantity squared, as n factorial times n factorial. All right? And so on the bottom, I have n plus 1 factorial and n minus 1 factorial. Let's see if we can simplify this a little bit. I notice that on the bottom, I have n plus 1 factorial, which is just going to be n plus 1 times n minus 1 times n minus 2 all the way down to 1. All right? On the top, for my first one, I have n factorial. My second one, I have n factorial, which is n times n minus 1 times n minus 2 times n minus 3 all the way down to 3 times 2 times 1. So that second value is going to be n minus 1 factorial. And on the bottom, I have n minus 1 factorial. So notice my n factorials are canceled. My n minus 1 factorials are canceled. And so that leaves me with just n over n plus 1. And the problem says that this is equal to 7/8. And notice if that n equals 7, on the bottom n plus 1 or 7 plus 1 is 8. So my final answer, n is equal to 7. And for challenge problem number 4, we have a rectangle that's 8 by 6. And on the exterior, we have squares that are joined together. We have the centers of all those squares form a quadrilateral. The question is, what is the area of this quadrilateral right here? Well, I know that the area of the rectangle in the very inside is going to be 48. And so let's see if we can figure out the area of these other values, and then we can just add them all together. Notice that this is a quarter of the square, and this is a quarter of the same size square. Now this square is 8 by 8, right? And 8 times 8 is 64, which means a quarter of that is going to be 16. And so if I add it to this 16, I would get 32. So the rectangle in the middle is 48, and the two top and bottom triangles form together to make 32. This is 6 by 6, which is a 36 square inch square, right? And a quarter of that 36 is 9, which makes this also equal to 9. So there's another 18, and if I add those all together, my final area is 98 inches squared. So there are 3 quick review topics that I just want to give you that will kind of encompass all of the review topics that you're going to see on Delta Math today. And the first one, we'll call this number 1, is to find secant of 150 on the unit circle. And we want to remember that all of our values up until this point will be exact values. So this unit circle right here will be very valuable to you. The first thing that we need to remember are the 6 ratios that go along with the unit circle. And I'll write these down. Okay, I know that we have talked about these quite a bit over the last couple weeks, but still good to know when we're looking for angles and values on the unit circle. So let's go ahead and find 150 degrees, and your answers could also come into radians, but I find on my unit circle that 150 degrees is here, which corresponds to the point -√3/2, 1/2. Now I notice from here that secant is 1/x, which means that secant of 150 is going to be 1 divided by the x value found at 150 degrees, and the x value found at -150 degrees is -√3/2. Just to simplify that a little bit very quickly, 1 over a fraction is the same as the reciprocal of that fraction, so let's call that -2/√3, and if I rationalize by multiplying it by itself, we can go ahead and call this -2√3/3. So that's the exact value of secant of 150. So we have quite a few problems, blah, 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 blah. Let's move on to example 2. If I give you a triangle that looks something like this, with 2 sides that are given, let's call this 55, and let's call this 48. I'm going to put a theta right here. And a lot of some of these review questions are from the 8.1 section that I taught a couple weeks ago. The question is to find all 6 values, or all 6 trig function values. Now, just like the y value of the unit circle, I could also think of this as opposite over hypotenuse, which means cosecant is hypotenuse over opposite. Cosine is going to be adjacent over hypotenuse. This is the reciprocal. So we can use those values to evaluate the 6 trig functions in the triangle. Now the problem is that we have this value that's missing, so let's go ahead and do the Pythagorean theorem very quickly. So using the Pythagorean theorem, it looks like my hypotenuse is 73. And so on, if we go ahead and have sine of my angle theta is opposite over hypotenuse, let's call that 55/73, which then means that cosecant of my angle is 73/55. Cosine is adjacent over hypotenuse, let's call that 48/73, which means secant of my angle theta is going to be 73/48. And finally, tangent of my angle theta is opposite over adjacent, which is going to be 55/48, which means that cotangent of my angle theta is 48/55. Topic 2 complete. Let's move on to topic number 3. So topic number 3 says that if tangent of theta is 6/5, find sine of theta, and they do tell us that we are going to be in quadrant 1. So the one thing that we have to do, if we could maybe just draw a little picture, right? If I could just put my angle up here in quadrant 1 somewhere and drop this down to make a little right triangle, and if this is going to be my angle theta, tangent, which we have identified from the first two questions is opposite over adjacent, also known as y over x. So the y value would be 6 because that's opposite, and the x value would be 5. They want us to find sine of theta. I'm going to give you two options on how you can solve this question. Option number 1 would be to use the Pythagorean theorem. My hypotenuse is the square root of 61. And from the first two questions, I can see that sine is opposite over hypotenuse, which means that sine of theta is going to be opposite 6 over the hypotenuse root 61, which we can call this root 61 over 61. So there's the exact value of sine theta. And for option 2, we can go ahead and use one of our identities. I have an identity that says tangent is equal to sine over cosine. Well, if I'm looking for sine, what I could do is multiply both sides by cosine of my angle here. And what I'm looking for now is cosine times tangent. Well, I know that tangent is 6/5, so let's go ahead and substitute that in here. All right? And if I look back on my triangle, cosine is adjacent over hypotenuse. So let's say that cosine is 5 over root 61, which says sine of my angle theta. My 5's would cancel. My final answer is going to be 6 over root 61, which then again simplifies to 6 root 61 over 61. Final.
From a distance.